Let's talk about effect of solvent on a solute. We want to discuss this by first looking at an experiment, and this is the experimental procedure. Dissolve hydrogen chloride gas in water. Divide the solution into 3 portions. To the first portion, place magnesium ribbon. Then test the second portion with the litmus paper. To the third portion, add magnesium carbonate. Then record your observation. Repeat this experiment by dissolving hydrogen chloride gas in methyl benzene. Which is an organic solvent. Then also record your observations. Observations and explanations. Let's look at observations and explanations. A solution of hydrogen chloride in water display acidic property. By turning blue litmus paper red, another one, reacting with magnesium or any metal to form magnesium chloride and hydrogen gas, also reacting with magnesium carbonate to form magnesium chloride, carbon 4 oxide, and water. And during that, it produces effervescence, or simply bubbles. It's also capable of reacting with bases to form salt and water, can conduct electric current, and during that will produce bright light. Reason being that the hydrochloric acid formed is able to ionize fully to give hydrogen ions and chloride ions. Now, what happens there is that water is a polar solvent, and that polar solvent has negative and positive charges. So let's check on that. So when it is dissolved in water which has a polar solvent, and you can see it has partial charges. This water molecule consists of one oxygen atom and two hydrogen atoms. Since the oxygen has a higher ability to attract bond electrons compared to hydrogen, meaning oxygen is more electronegative. The bond pairs of electrons are closer to oxygen atom in the water molecule, leading to the oxygen atom developing a partial negative charge, while the hydrogen will now develop a partial positive charge. We have said oxygen is more electronegative. It has high ability to attract a bonded pair of electrons. And a molecule which behaves as if it is negatively charged in one end and positively charged in one end is said to be polar. And that's why water is a polar solvent. We have said a molecule which behaves as if it is negatively charged in one end and positively charged in the opposite end is said to be polar. Therefore, water qualifies to be called a polar solvent. Remember, hydrogen chloride is also polar. It has hydrogen ion and chloride ion, negative and positive on different ends. And this is because chlorine has a higher ability to attract bond electrons compared to hydrogen. The chlorine end of the molecule, therefore, will develop a partial negative charge as the hydrogen end develops a positive charge. Meaning, now water has negative and positive ends. Hydrogen chloride also has negative end and positive end. Now, when this hydrogen chloride is dissolved in water, different water molecules attract both ends of hydrogen molecules, causing it to dissociate. You can see that attack and that attack, and that make it to dissociate. This implies that the covalent bond is broken in such a way that the shared pair of electrons are left with the chlorine atom, thus creating negatively charged chloride ion and positively charged hydrogen ion. From that dissociation, this is what we have. After that solubility, the formed hydrochloric or simply hydrogen chloride gas dissolves in water to give hydrogen ion and chloride ion. And the presence of these hydrogen ions is what brings acidity. So that makes this one acidic. And therefore, this same presence of hydrogen ion is what will now make it to turn blue litmus paper red, react with magnesium carbonate to liberate carbon 4 oxide. It is this same thing that will make it to react with magnesium to liberate hydrogen gas. And it is this same presence of ions after dissociation that will enable electrical conductivity. Now, it is clear that the hydrogen ions will now be able to react with the magnesium carbonate, and that gives magnesium ion carbon 4 oxide and water. So the carbon 4 oxide and water is just formed between from the reaction between the acid and the carbonate due to presence of hydrogen ion, and by having that there, our equation is balanced. Now the story is that the hydrogen chloride gas, it is able to ionize in water, and we have explained that because of simply polarity of water. Being that hydrogen chloride is polar, water is also polar, hydrogen chloride is able to dissolve and ionize to give the mobile ions that will enable conductivity, will also enable production of effervescence. That is when it is reacted with either magnesium or magnesium carbonate. What happens to the case of methyl benzene? Methyl benzene is nonpolar solvent. And when hydrogen chloride gas is dissolved in methyl benzene, its molecules do not dissociate. Well, it will dissolve because both of them are are covalent in nature. So because of the covalence nature, it will just dissolve. But remember, its molecules, that is the molecule of hydrogen chloride, does not dissociate into hydrogen ion and chloride ion. And therefore, no hydrogen ion is present. No present hydrogen ion. And because of that, there is no effect on litmus paper, especially the blue that should turn red, does not react with both magnesium and magnesium carbonate. So there is no production of effervescence. So if we test for the electrical conductivity, then the bulb will remain dim, because methylbenzene does not allow hydrogen chloride gas to ionize to give mobile ions. And because of the absence of mobile ions, the result we have mentioned above will take place. Similarly, we can also look at the behavior using a base. Similarly, ammonia gas only shows basic property in water, and reason is that it is able to ionize to give ammonium ion and hydroxyl ion, and the presence of hydroxyl ion will be responsible for the basic property. In methylbenzene, it does not show basic property. Because ammonia remains a molecule. Here, ammonia remains a molecule. So it will not be able to react as a base. It does not produce the hydroxyl ion and fully remains as a molecule, hence no basic property. That is all about the effect of a solvent on a solute.